Hello students, how are you all? I hope you all good. And today we are going to discuss inverse circular functions exercise number 2 in that 17 to 25 problems. Solve the following equations. Okay, so this video and next video you have to concentrate more. After that I am going to conduct an exam. Alright, so now before going to our class, let's close our eyes, then we can do our prayer. God, kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Alright, let's move on to our 17th problem. That is secant inverse x upon a minus secant inverse x upon b is equal to secant inverse b minus secant inverse a. So you have to use these formulas. Secant inverse x is equal to cos inverse 1 upon x. Cos inverse x plus cos inverse y is equal to cos inverse xy minus square root of 1 minus x square root of 1 minus y square. So this formula we have to use, and it is very simple question. So let's move on to this. Alright, these two formulas very important. That is secant inverse x is equal to cos inverse 1 upon x. Cos inverse x plus cos inverse y is equal to cos inverse xy minus, here 1 square root also you can write. So 1 square root 1 minus x square into 1 minus y square. So that two formulas you have to remember before going to solve this. See here, a send one side, b send one side. So now sec inverse x upon a, here minus sec inverse a comes to here plus sec inverse a, that is equal to here minus sec inverse x upon b, go to that side, sec inverse x upon b, here plus sec inverse b. So can I write a as a upon 1, b as b upon 1? So why I am writing here, it is, you already know that sec inverse x is equal to cos inverse 1 upon x. Change everything in the cos form. So then cos inverse a upon x if you take reciprocal. Same method here, cos inverse 1 upon a. Here cos inverse b upon x plus cos inverse 1 upon b. So now you observe carefully here, what is formula now? Cos inverse x plus cos inverse y is equal to cos inverse xy into xy minus square root of 1 minus x square into 1 minus y square. So now what I need to do here, it is just observe, just apply this formula. When you apply, here you get cos inverse x into y. X into y, here x is a upon x and y is here 1 upon a. So minus square root of 1 minus x square, 1 minus y square. So 1 minus x square means here a square upon x square. So write that a square upon x square. Next one here, 1 minus y square. So 1 minus y square means 1 square is 1. A square means a square, so that this you are going to get here. And same method what you get here. So here you can write cos inverse x is b upon x, y is 1 upon b, minus square root of 1 minus x square means 1 minus b square upon x square, because x is here b upon x. So into 1 minus y square means 1 square means 1, b square means b square. So after completion of this, you are observing here also cos inverse, here also cos inverse. So comparing corresponding elements. When you compare these both, that comparing corresponding elements, if you do, what will happen? This cos inverse will go off, whatever remaining left that we get. So first here a cancel, b cancel. So then we can solve it. 1 upon x minus square root of 1 minus a square upon x square into 1 minus 1 upon a square. So that is equal to what we can write here again, 1 upon x minus then square root of 1 minus b square upon x square into 1 minus 1 upon b square. So now what I'll do here, just observe carefully. Here 1 upon x, here also 1 upon x, that both get cancelled. So once these both are cancelled, then what is remaining here? Minus square root, then squaring on both sides I'll do. So once if you do squaring on both sides, what we get? Squaring on both sides. So when you do squaring on both sides, square and root get cancelled. So directly I am writing remaining part. So now 1 minus a square upon x square into 1 minus 1 upon a square, that is equal to 1 minus b square upon x square into 1 minus 1 upon b square. So now just multiply it, what you are going to get now. So I think so you are completed up to here. Then again I will start this step onwards back. Okay. So this is about our last step. I just multiply 1 into 1, 1. So I can write this as 1 into 1, 1. 1 minus 1 into 1 upon a square means 1 upon a square. So then minus a square upon x square into 1 means minus a square upon x square. Then minus into minus plus a square upon x square into 1 upon a square upon x square into 1 upon a square is equal to, what is here again same, 1 into 1, 1 minus 1 into b square, 1 upon b square, then minus b square upon x square into 1 minus b square upon x square, minus into minus plus b square upon x square into 1 upon b square upon x square into 1 upon b square. So now how to simplify this? Now a square get cancelled, b square get cancelled. So then what are the remaining? 1 get cancelled, minus 1 upon a square minus a square upon x square plus 1 upon x square is equal to minus 1 upon b square minus b square upon x square plus 1 upon x square. 1 upon x square get cancelled. Now these two minus symbols are there, send that side, and these two also having minus symbols, send this side. So this becomes as a plus. So now 1 upon b square plus b square upon x square, that is equal to, now here 1 upon a square plus a square upon x square. Now x square is one side this side, a square b square send that side. So what you are going to get? So now b square upon x square plus a square upon x square comes to here minus a square upon x square, that is equal to 1 upon a square plus 1 upon b square, go to that side, minus 1 upon b square. Now take LCM here, b square minus a square upon x square is equal to, here also b square minus a square, b square once a b square, a square once a square, upon LCM is a square b square. Cancel these two. Then what is possibility to get at last? So if b square cancel, then you get at last, here it is last step before, 1 upon x square is equal to 1 upon a square b square. Then just do cross multiplication, a square b square is equal to a square b square once a square b square x square into 1 x square Then x is equal to what you get? Square root of a square b square. So square x is equal to you got as square root of a square b square. This is all nothing but plus or minus ab. So at last what is our answer? Therefore x is equal to plus or minus AB. So this is what solve the following. Solve the following question number 17 to 25. 17th question is this. So I hope you all understood this 17th question. Let's move on to the 18th question now. Alright, next question we are going to discuss, that is 18th one. Cos inverse x square minus 1 upon x square plus 1 plus tan inverse 2x upon x square minus 1 is equal to 2 pi upon 3. This equation you have to solve. Before going to solve this, these two formulas you have to remember. One is cos inverse x is equal to pi minus cos inverse minus x, or you can say that cos inverse minus x is equal to pi minus cos inverse x. And tan inverse 2x upon 1 minus x square is equal to cos inverse 1 minus x square upon 1 plus x square is equal to 2 tan inverse x. These two you have to remember before going to solve this problem. And now it is very simple. Now it is think that cos inverse x. Then how can I write? Pi minus cos inverse minus x. So how can I write this part? Just observe carefully now. So this we can write it as cos inverse. If you keep minus inside, then minus becomes plus, plus becomes minus. So cos inverse 1 minus x square upon 1 plus x square. But what I need to write here? Pi minus. That is very important. So it is your solution. So you need to write pi minus cos inverse 1 minus x square upon 1 plus x square. So now first part completed. Then what about second one? Plus, see here, I want here as 1 minus x square, common here minus. So then what will happen? This plus becomes as minus. If you keep here minus symbol, this both you can interchange. So then tan inverse 2x upon 1 minus x square is equal to 2 pi upon 3. Now pi minus cos inverse 1 minus x square, 1 plus x square means what do you know? 2 tan inverse x, write that. Minus tan inverse 2x upon 1 minus x square, also 2 tan inverse x, write that. 2 pi upon 3. Now send here, and these two minus 2 tan inverse x minus 2 tan inverse x, send that side. What you are going to get? So then pi minus 2 pi upon 3, because here plus 2 pi upon 3 comes to here minus 2 pi upon 3. That is equal to minus 2 tan inverse x, go to that side, plus 2 tan inverse x. Again minus, go to that side, plus 2 tan inverse x. Now just do subtraction. This becomes as 3 pi minus 2 pi is nothing but pi upon 3. So that is pi upon 3 is equal, because here 3 into pi, 3 pi minus 2 pi is nothing but pi upon 3 is equal to 4 tan inverse x. Now 4 here what is doing? Multiplying comes to here division. So then pi upon 3 into 4 is equal to tan inverse x. So now here tan inverse is there, comes to here tan. So then x is equal to what was? Therefore x is equal to tan pi upon 3 fours are 12. So tan pi upon 12. So therefore what is your x? Tan pi upon 12. So at last here I will write, therefore x is equal to tan pi upon 12. So that is about your answer. So this is about your problem number 18. So if you have any doubt in this, you can comment on YouTube session so that I can help you all and you can understand easily. So this is about your 18th, and let's move on to the 19th problem. Let's move on to the 19th problem. Tan inverse 1 upon 1 plus 2x plus tan inverse 1 upon 4x plus 1 is equal to tan inverse 2 upon x square. So here used formula tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. This formula we used, and let's move on to the problem now. This is our solution. So here what is that? Tan inverse x plus tan inverse y. Tan inverse x plus y upon 1 minus xy. So just write that as, directly I am writing tan inverse x plus y. So 1 upon 1 plus 2x plus 1 upon 4x plus 1 upon 1 minus x into y. X is 1 upon 1 plus 2x. Y is 1 upon 4x plus 1. Right, so that's close. That is equal to tan inverse 2 upon x square. So comparing corresponding elements, tan inverse go off, and whichever is there that, and take the LCM now. So first cross multiplication, 4x plus 1 into 1, 4x plus 1, 1 plus 2x plus 1 into 1 is nothing but plus 1 plus 2x, because 1 into any number that, and LCM here 1 plus 2x into 4x plus 1, that is upon, and here 1 plus 2x into 4x plus 1 into 1 means you get again same only, so write 1 plus 2x into 4x plus 1 minus 1 ones are 1 upon LCM 1 plus 2x into 4x plus 1, that is equal to 2 upon x square. Check now. This and this get cancelled. What is going to get? 4x plus 2x 6x plus 1 plus 1 2 upon 1 into 4x 4x, then 1 into 1 1 plus 2x into 4x, 2 4s are 8, x into x square plus 2x into 1 2x minus 1. So that is equal to 2 upon x square. Minus 1 plus 1 get cancelled. Then do the cross multiplication, then what you are going to get. So we need to do now cross multiplication. So when you do the cross multiplication, you get x square into 6x, 6x cube, x square into 2, 2x square, that is equal to, so now 2 into 4x, 8x plus 2 into 8, 16x square, then plus 2 into 2, 4x. So now all send to this side, and 6x cube plus 2x square plus 16x square comes to your minus 16x square. Now plus 8 plus 4 means that is 12, plus 12x comes to your minus 12x, that is equal to 0. So now 6x cube minus plus 2x square minus 16x square means minus 14x square minus 12x is equal to 0. Right. So now in all the plus 2x common, when you common 2x, so now here 2 3s are 6x square minus, and now here it is 7s are 14x, because x common, minus 2 6 are 12, that is equal to 0. So now here this is 2x, and then 3x square minus 7x minus 6. If you solve this, you get as factors as x minus 3, 3x plus 2. X minus 3 into 3x plus 2 you are going to get. You just do this splitting method, you are going to get that. So after completion of that, so what you need to do here, just 2x is equal to 0, x minus 3 is equal to 0, 3x plus 2 is equal to 0. Now x is equal to, here 2 is multiplying, go to that side division, so it becomes 0, x is equal to 3, and then here x is equal to minus 2 upon 3. So you got an answer, sir. X is equal to 0. So you got answer, sir. x is equal to 0, x is equal to 3, x is equal to minus 2 upon 3. So this is about your problem number 19. And if you have any doubts, you can comment on YouTube so that I can help you out. So this is about your 19. Let's move on to the 20. Alright, next question. That is 20 tan inverse x plus 7 upon x minus 1 plus tan inverse x minus 1 upon x is equal to pi minus tan inverse 7. In that we used formula as tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 plus xy. So now first here tan inverse x plus tan inverse y. So that formula we can apply. So what you are going to get now? Tan inverse directly I'm writing x plus y means x plus 7 upon x minus 1 plus x minus 1 upon x. That is upon 1 minus x is x plus 7 upon x minus 1 into y is, you can write as x minus 1 upon x. That is equal to pi minus tan inverse 7. Now what I'll write here again, tan inverse. So LCM take x into x square plus 7 into x 7x plus then x minus 1 into x minus 1 x minus 1 whole square, right? That is upon what is LCM x minus 1 into x, that is big upon x minus 1 into x minus 1 into x means x minus 1 into x minus x plus 7 into x minus 1. So here LCM is x minus 1 into x, that is equal to pi minus tan inverse 7. Now x minus 1 into x minus 1 into x get cancelled. So whatever is left that we need to write now. Tan inverse x square plus 7x plus a minus b whole square. A square plus b square minus 2ab. A square is x square, b square is 1 minus 2ab means 2 into x. So that is upon x into x square minus x into 1x plus x plus 7 into x minus 1. What you are going to get here, minus symbol is there. So let me write minus, then x into x square, x into 1 minus x plus 7 into x plus 7x. Then next one, what is left? 7 into 1 7. So that is equal to pi minus tan inverse 7. Still simplification is there. So tan inverse x square plus x square 2x square plus 7x minus 2x plus 5x, and then here plus 1. So write that plus 1 upon x square minus x minus sign inside minus x square minus into minus plus x minus 7x plus 7, that is equal to pi minus tan inverse 7. Here also cancellation, minus x plus x minus x square plus x square get cancelled. So at last what you are going to get in this place. So this is about that, and let me drop the first part and then again I'll solve for you all. So after cancellation, what is left here? Tan inverse 2x square plus 5x plus 1 upon minus 7x plus 7 is equal to pi minus tan inverse 7. So that you left, and now we are going right. Now again we have to apply tan inverse x plus tan inverse y problem formula. How it is? A minus tan inverse 7 comes to a plus. So right here tan inverse 2x square plus 5x plus 1 upon minus 7x plus 7 plus tan inverse 7 is equal to pi. Now tan inverse x plus tan inverse y. So again tan inverse, so x plus y, and so that means 2x square plus 5x plus 1 upon minus 7x plus 7 plus here it is 7 upon 1 minus 2x square plus 5x plus 1 upon minus 7x plus 7 into, we'll get here answer is 7. So that is tan inverse, that is equal to I. So now what I'll do here, it is here tan inverse, go to that side, tan. So now you can write this as 2x square plus 5x plus 1, just multiply, plus 7 into minus 7 minus 49x. Now 7 sevens are 49, that plus 49, that is upon whatever is there, right as it is, 1 minus 2x square plus 5x plus 1 upon minus 7x plus 7 into 7, this will in bracket, that is equal to tan pi. But what do you know tan pi value? Tan pi is nothing but 0. So now you just write here 2x square plus 5x plus 1 minus 49x plus 49 upon whatever is there, that big bracket, 1 minus 2x square plus 5x plus 1 upon minus 7x plus 7 into 7. See, you want to simplify, you can simplify also, but I am not simplifying. The reason behind, 0 is there and here in the denominator place, it goes to that side, it multiplication, multiplied, 0 is multiplying with any number, you get answer as 0. So because of that reason, I am not at all simplifying this part. So now this part send that side, it becomes a 0. So now what do you get here? 2x square minus 49x plus 5x. So you get as minus 44x. Next, plus 1 plus 49. So that is plus 50 is equal to 0. Now, that 2 also you can common, then what you are possible to get? Because here 0 into this full part becomes as a 0. So now 2 common, then you get as x square minus 22x plus 25 is equal to 0. 2 here it is, multiplying, go to that side, division. So x square minus 22x plus 25 is equal to 0. Now it is in the form of ax square plus bx plus c is equal to 0. Anything in this form, what is your formula? X is equal to minus b plus or minus square root of b square minus 4ac upon 2a. So you write this formula, and what is here? A is nothing but here nothing is there, means 1, b is minus 22, c is 25. Just substitute those, you are going to get your answer as this, that is you will get answer as 11. So x is equal to, you are going to get as 11 plus or minus 4 root 6. 11 plus or minus 4 root 6. See, here I am not solving this part, you have to solve and then you have to write this part. That is only your homework in this problem. Okay, so x is equal to 11 plus or minus 4 root 6. Your homework is just substitute ABC values and get answer as 11 plus or minus 4 root 6. So that is about your problem number 20. So now we are going to the problem number 21. Alright, let's move on to the problem number 21. Sin inverse 1 upon root 5 plus cot inverse x is equal to pi upon 4. This you need to solve. Before going to solve, remember these all formulas. Sin inverse x is equal to cosec inverse 1 upon x. Cosec square y is equal to 1 plus cot square y. And cot inverse x plus cot inverse y is equal to cot inverse xy minus 1 upon x plus y. So now that we need to remember. Then solution, you just observe carefully here. First I think this sin inverse, let sin inverse 1 upon root 5. So first anyhow this is equal to, I may think as y. And you know that sine inverse 1 upon root 5 is nothing but like sine inverse x. Sine inverse x is equal to what you know, cosec inverse 1 upon x. So if I need to write as this as cosec inverse, then you can write cosec inverse. Reciprocal you have to take for that, then you get as root 5 upon 1 is nothing but root 5. So sine inverse 1 upon root 5 is nothing but cosec inverse root 5 according to this formula, that is equal to y. And now here cosec inverse is there, go to that side, cosec. So now cosec y is equal to root 5. Now what I will do is squaring on both sides. Squaring on both sides. When you do squaring on both sides, cosec square y is equal to root 5 whole square. Square and root get cancelled. Then cosec square y is equal to, you get answer as 5. But you know that cosec square y is nothing but 1 plus cot square y. Just substitute here. 1 plus cot square y is equal to 5. Here plus 1, go to that side, minus 1. Then cot square y is equal to, we get as 5 minus 1. So that is again we can write it as cot square y is equal to, we can write it as 4. Then cot y is nothing but square root of 4, that is cot y is equal to plus or minus 2. But when you are taking, only take positive one, that is cot y is equal to 2. So that is cot y is equal to 2 we have to take. So now let me substitute sine inverse 1 upon root 5 is equal to y in this equation, so that it becomes as easy now. So now sine inverse 1 upon root 5 is nothing but what do you know here, y plus cot inverse x is equal to pi upon 4. And this implies what we can get now. So here it is cot is there, go to that side, cot inverse. So then y is equal to cot inverse 2. So wherever y is there, substitute cot inverse 2. So right here cot inverse 2 plus cot inverse x is equal to pi upon 4. So now here it is cot x plus cot y is equal to. So cot x plus cot y means cot inverse xy minus 1 upon x plus y. Just substitute that. So then you can write here cot inverse xy, 2 into x, 2x minus 1 upon x plus y means 2 plus x, that is equal to pi upon 4. Now here cot inverse, go to that side, cot. So we can write it as cot pi upon 4. So just you can write here it is 2x minus 1 upon 2 plus x is equal to cot pi upon 4. So cot pi upon 4 is nothing but what do you know? It is nothing but 1. So now just I'll write the remaining part here, that is 2x minus 1 upon 2 plus x is equal to 1. Now just cross multiplication, 2x minus 1 is equal to 2 plus x into 1, 2 plus x. So now x send here, minus 1 send that side, plus x comes to here, minus x, that is equal to minus 1, go to that side, plus 1, 2 plus 1, 2x minus x is equal to 2 plus 1 is nothing but 3. So therefore x is equal to 3. This is about your answer. If you have any doubt, you can ask me in the YouTube so that I can help you all. This is about your problem number 21. Like this you have to solve. So now let's move on to the problem number 20. Let's move on to the problem number 22. 3 tan inverse 1 upon 2 plus root 3 minus tan inverse 1 upon x is equal to tan inverse 1 upon 3. And now you have to remember these formulas. You have to remember these formulas. 3 tan inverse x is equal to tan inverse 3x minus x cube upon 1 minus 3x square. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. So let me take this part and then solve. So now before going to this, here you found as 1 upon 2 plus root 3. Take the RF and simplify it. So RF of this is 2 minus root 3 Here also 2 minus root 3. Then what you get? 1 into 2 minus root 3, 2 minus root 3 upon a plus b, a minus b, a square minus b square. A square is nothing but 2 square minus b square nothing but root 3 whole square. Cancel it. 2 minus root 3 upon 4 minus 3. That is nothing but 2 minus root 3 upon 1. That is nothing but 2 minus root 3. So 1 upon 2 plus root 3 means I can write it as 2 minus root 3 after taking RF and multiplying and get answer as 2 minus root 3. So I'll substitute wherever 1 upon 2 plus root 3 is there 2 minus root 3. Okay. So now let me substitute in that way 2 minus root 3. Just remember it how to solve that part. I'm not going to write that part now. Okay. So let me go for it. Now 3 tan inverse 2 minus root 3 minus, here minus is there, go to that side, plus. So anyhow is equal to tan inverse 1 upon 3 minus is there, go to that side, plus and tan inverse 1 upon x. So now it is 3 tan, this full as think as x, 3 tan inverse x. Tan inverse 3x minus x cube upon 1 minus 3x square. Apply that. So now I can write this as tan inverse 3 into x. 3 into x is nothing but 2 minus root 3 minus x cube means 2 minus root 3 whole cube upon So next what is the 1 minus 3x square. 1 minus 3 into x square is nothing but 2 minus root 3 whole square. So that is equal to, we can write it as here tan inverse 1 upon 3 plus tan inverse 1 upon x. Tan inverse x plus tan inverse y. Tan inverse x plus y means 1 upon 3 plus 1 upon x upon 1 minus 1 upon 3 into 1 upon x. Just simplify what we are going to get. So right here tan inverse 3 2s are 6 minus 3 into root 3, 3 root 3 minus a minus b whole cube. So a cube means 2 cube, that is nothing but 2 2s are 4, 4 2s are 8. Then minus b cube is nothing but root 3 whole cube, that is nothing but 3 root 3, because root 3 whole cube means you can write root 3 square into root 3. So root 3 square is nothing but 3 and then root 3. So a cube minus b cube minus 3a square b. So 3a square is nothing but 2 square, 2 square is nothing but 4, b is nothing but root 3. Next plus 3a square b. So 3ab square. So now here 3a is nothing but 2, b square is nothing but root 3 whole square. Root 3 whole square is nothing but 3. So now completed this a minus b whole cube formula upon 1 minus b into a minus b whole square. A square means 2 square, that is 4, plus b square means root 3 whole square, that is nothing but 3, minus 2 into a into b. 2 into 2, 4 and root 3. So 4 root 3. This full bracket, that is equal to tan inverse LCM take x 1s are x plus 3 1s are 3 upon 3x upon 3x 1s are 3x minus 1 upon 3x. Now 3x get cancelled, and here anything is cancellation is possible. Let me check. So next step, tan inverse 6 minus 3 root 3 minus 8 minus into minus plus 3 root 3 again minus into minus plus 3 4s are 12 root 3, then minus into plus minus 3 3s are 9, 9 2s are 18 upon 1 minus 3 fourths are 12 plus into minus minus 3 3s are 9 minus into minus plus 3 fourths are 12 root 3 that is equal to tan inverse x plus 3 upon 3x minus 1. So now you just observe this is what the simplification we got. Now comparing corresponding elements, because here also tan inverse, here also tan inverse. So comparing corresponding elements. When you compare corresponding elements, that all tan inverse can go off. So let me write here comparing corresponding elements and those. So in the front, I hope you all understood up to this step. Now you'll write comparing corresponding elements, that is CCE. So now in this place simplification, let me check. Minus 18 minus 8. So minus 18 minus 8 both are minus symbols. So add first 18 plus 8 is nothing but 26. 26 plus 6 minus 26 plus 6 is nothing but minus 20. So write that minus 20 because tan inverse are removed after CCE. Next, minus 3 root 3 plus 3 root 3 get cancelled, and what is left here? 12 root 3. So plus 12 root 3 upon here now. Minus 9 minus 12 minus 21 minus 21 plus 1 minus 20. Then plus 12 root 3. Same only you got. That is equal to x plus 3 upon 3x minus 1. Now again very simple. These both get cancelled, get answer as 1. Then cross multiplication. 1 into 3x minus 1, 3x minus 1. That is equal to, here also 1 into x plus 3, x plus 3. Now, x in here, 3x minus x is equal to, minus 1 go to that side, plus 1, 3 plus 1. 3x minus x, 2x is equal to 4, 2 1s, 2 2s. So x is equal to 2. Therefore, x is equal to 2. That is about your problem number 22. So I hope so you all understood. Let's move on to the problem number 23. Alright, let's move on to the problem number 23. Sin 2 cos inverse cot 2 tan inverse x is equal to 0. This we need to solve. Before going to this problem, you need to remember 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. Tan inverse x is equal to cot inverse 1 upon x. Cos inverse x is equal to sin inverse square root of 1 minus x square. 2 sin inverse x is equal to sin inverse 2x square root of 1 minus x square. Remember those and it becomes very easy. Now first, Bodmer's rule apply. 2 tan inverse x whatever is there, that substitute. So now I'll write sin 2. This is about your solution. Now cos inverse bracket flower bracket cot 2 tan inverse x means what do you know? Tan inverse 2x upon 1 minus x square, and then bracket close, flower bracket close, box close equal to 0. Now this tan inverse convert into the cot form, that is tan inverse x is nothing but cot inverse 1 upon x. So now sin 2 cos inverse cot inverse, just reciprocal it, 1 minus x square upon 2x is equal to 0. Now, first one already completed. Right, next, here it is sin. So next one it is, just you can write sin 2 as it is. It is sin 2. What happened? Sin 2 cos inverse, cot to cot inverse get cancelled. What is left now? 1 minus x square upon 2x. Yes, cot inverse theta is nothing but theta. So that is equal to 0. Now cos inverse is there. This in the form of sine I want. So what I can do? So you know that cos inverse x is equal to sine inverse square root of 1 minus x square. So now here this is your x. 1 minus x square means, so let me solve here separately. So that is 1 minus x square means 1 minus x square upon 2x whole square. So then square a by b upon whole power m, that is a power m upon b power m. 1 minus x square whole square upon 2 square is nothing but 4x square. 4x square into 1, 4x square minus a square is nothing but 1, b square is nothing but x power 4, x square whole square is nothing but x power 4, and then minus 2 into a into b. So 2 into 1, 2x square. Just I applied a minus b whole square formula upon 4x square. So now when you simplify it, my 4x square. So I think I need to write here this simplification. So that is 4x square minus plus 1 becomes as minus 1 plus x to the power 4 minus x to the power 4 minus into 1 is plus 2x square upon 4x square. That is nothing but 4x square plus 2x square 6x square. So minus x to the power 4 minus 1 plus 6x square upon 4x square. So at last you are going to get as this 6x square minus 1 minus x power 4. So upon 4x square. So now wherever this cos inverse is there, if I want to convert into the sine inverse, square root of 1 minus x square, this is your 1 minus x square. So that should be under the root we have to write now. So can I write now here? So here itself I'll complete this part. So sine 2, this cos inverse changing into the sine, that is sine inverse square root of 1 minus x square means this you got, that is 6x square minus x power 4 minus 1 upon 4x square. So this you got, that is equal to 0. So I hope so you understood this, how you got this part. Because cos inverse x is equal to sine inverse square root of 1 minus x square. 1 minus x square, how to solve? Separately I was solved. I got answer as square 6x square minus x power 4 minus 1 upon 4x square. So this, if you want to write sine inverse form, sine inverse. So now this full you take now sine. 2 sine inverse square root is there. So here it is 2 sine inverse. So 2 sine inverse x means sine inverse 2x square root of 1 minus x square. Again for this. So it is a big one, but we have to complete. There is no other option for us, right? So it is very easy also, but sine. So now 2 sine inverse you have to change as sine inverse. So I am writing here sine inverse. So 2x is nothing but, here I will write big box. So 2x means 2 into x is nothing but square root of 6x square minus x power 4 minus 1 upon 4x square is nothing but, what can I write this? This we can write it as 2x. So now 2x completed, then square root 1 minus x square. So 1 minus x square is nothing but this full whole square, right? So anyhow I will write that as 6x square minus x power 4 minus 1 upon 4x square whole square, and this bracket will close and this big bracket will close, that is equal to 0. I hope so up to here you all understood, and I will solve remaining part in the upside. Okay. Next, you know that sine inverse of sine of sine inverse theta is nothing but theta. So our sine of sine inverse x is equal to x. So x is nothing but only this part will come. You can write only that part. And anyhow, 2 get cancelled, right remaining what is there? Square root of, so 6x square minus x to the power of 4 minus 1. This is your 6x square minus x to the power of 4 minus 1 upon x, and then square root of this part again. Squaring on both sides means what you are going to get at this, this square and root get cancelled. What you are going to get now? 1 minus 6x square minus x power 4 minus 1 upon 4x square, that is equal to 0. So now this equal to 0 came, and what I can do now, still here x is the dividing, go to that side, multiplication 0 into any number 0 only, so that I don't want to consider it. Now square root of 6x square, this is 6 minus x power 4 minus 1, and here it is LCM take, then here 4x square is LCM, 4x square 1, so 4x square minus 6x square, minus into minus plus x power 4, again minus into minus plus 1, that is equal to 0. And now here square root of 6x square minus x power 4 minus 1, and again here square root of 4x square minus 6x square, you get as minus 2x square. So here minus 2x square plus x power 4 plus 1 upon 4x square means you can write it as 2x is equal to 0. Here 2x dividing, go to that side, multiplication 0 into any number, 0 only you are going to get. So now what I will write next part is this, that is square root of 6x square minus x power 4 plus 1, minus 1, and then again here square root of minus 2x square plus x power 4 plus 1 is equal to 0. Now squaring on both sides, then square roots get cancelled. 6x square minus x power 4 minus 1 into minus 2x square plus x to the power of 4 plus 1 is equal to 0. Now first one equal to 0, second part equal to 0. So again this part is very easy one. I am writing upside because these steps I hope so you all are written. If you are not written, pause the video and then you can write down. So at last here two equations you got. Equation number 1 is this, I will take first write in the order x power 4. So let me check back. Okay, first one it is x power 4 minus 2x square plus 1 is equal to 0 means, and second one it is minus x power 4, so I write this as minus x power 4 plus 6x square, and then minus 1 is equal to 0. Here all minus common, then x power 4 minus 6x square plus 1 is equal to 0. Now from this equation, can I write this as x square whole square minus 2 into x square into 1 plus 1 whole square. So check now, a square minus 2ab plus b square. So that means a minus b whole square, that is x square minus 1 whole square is equal to 0. That means x square minus 1 is equal to 0, x square is equal to 1, x is equal to plus or minus 1. So this is about your first equation 1. Then now we are going to the equation number 2 also. That is equation number 2 is this. So we need to make this in the a plus b whole square form. So how it is? X square whole square. So means a square is this. Then how we need to know b square? By using this. So now how can we do that as minus? You know that 2 into a is nothing, b is, a is nothing but x square, 2 into a into b. B should be what is here? 3. Then only 3 2s are 6. So here you need to write plus 3 square. So that it becomes as a minus b whole square plus 1. So value we don't want to change it. That's what if you are added here 3 square, go to that side also add 3 square. So that 0 plus 3 square we can write. So then what I can write here? So this becomes as a minus b whole square, that is x square minus 3 whole square. Next plus 1 is equal to here 0 plus 3 square is nothing but 9. Here plus 1 go to that side minus 1. So x square minus 3 whole square is equal to 8. 9 minus 1 is nothing but 8. Then here square, go to that side square root. So x square minus 3 is equal to square root 8 is nothing but plus or minus 2 root 2. Okay. So now take plus, one answer you get, take minus, another answer you will get. Or you can write this as x square is equal to minus 3, go to that side plus 3. 3 plus or minus 2 root 2. Right? And here square is there, go to that side, it becomes as a square root. So when it becomes as a square root, then we will get remaining answer after applying that square root value. Okay. So how to do this part? So this we can write it as still we can write this as x is equal to square root of 3 plus or minus 2 root 2, and again plus or minus. So when you solve this square root of 3 plus or minus 2 root 2, then you get x is equal to plus or minus 1 plus root 2. So this you are going to get. So if you want, you can check that one, that is 1 plus root 2 whole square formula check, then you are going to get this answer only. This is about your answers for your problem number 23. I hope so you all understood this. If you are not understood, you can ask me so that I can help you all. Okay, so that is about your problem, and I hope so you all understood. Let's move on to the next problem, that is problem number 24. Alright, next 24th problem. This is our homework for you, 25th also homework. And here tan inverse x, tan inverse 1 upon 4 plus tan inverse 1 upon 6 plus tan inverse 1 upon x plus 2 tan inverse 1 upon 5 is equal to pi upon 4. This you have to solve. Use formulas as tan inverse x plus tan inverse y plus tan inverse z is equal to tan inverse x plus y plus z minus xyz upon 1 minus xy minus yz minus zx. That formula you have to use for these three. Okay, and then 2 tan inverse x, tan inverse 2x upon 1 minus x square. This formula you have to use here, and then when you solve this part here, tan inverse will come. This becomes as tan inverse tan inverse x, and this becomes as tan inverse y. Then you can use tan inverse x plus tan inverse y formula. That is, what do you know? Tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy. That after using that, then tan inverse go to that side, tan pi upon 4 you get, that as 1. You substitute, you get x as answer minus 461 upon 9. If you are not getting, you can comment on YouTube so that I can help you all. This is about your 24th, but You have to try yourself. If you are not getting, then only ask me. So this is about your 24th, and let's move on to the 25th. Alright, last problem for today. That is 25th one, sin inverse x plus sin inverse y is equal to pi upon 3, and cos inverse x minus cos inverse y is equal to pi upon 3. And you have to use cos inverse x is equal to pi upon 2 minus sin inverse x. Actually, I thought this also I need to give as homework, but anyhow, one problem homework is okay. So I'm going for again 25th problem to explain. So now it is again very easiest problem. This gives us equation number 1, and this simplify by using this. Cos inverse x means what do you know? Pi upon 2 minus sin inverse x. Minus cos inverse y is nothing but again pi upon 2 minus sin inverse y. Here y is there, that's what y is equal to pi upon 3. Just simplify it. Pi upon 2 minus sin inverse x minus pi upon 2 minus into minus plus sin inverse y is equal to pi upon 3. Get cancel. Minus sin inverse x plus sin inverse y is equal to pi upon 3. Let's give equation number 2. Now first add 1 and 2. Add this solution directly I am doing. Add 1 and 2. When you do adding, sin x minus sin x cancel. Then minus plus sin y 2 sin inverse y plus 2 sin plus sin inverse y plus 2 sin inverse y is equal to add here 2 pi upon 3 plus pi upon 3. So this becomes as like fraction solution 3 pi upon 3. So this is 2 sin inverse y. 3 get cancel. Sin inverse y is equal to pi. Here it is 2 is multiplying, go to that side, division pi upon 2. So then y is equal to sin pi upon 2. Sin pi upon 2 means sin 90 degrees, that is nothing but 1. So y value is 1. Same thing here, now subtract. So right here subtract, that is 2 from 1. 2 from 1. Subtract 2 from 1. So then when you subtract 2 from 1, then what will happen? Here it is minus of minus sin x plus sin x, sin inverse x plus sin inverse x, 2 sin inverse x. And this becomes minus plus sin inverse y minus sin inverse y get cancelled. That is equal to 2 pi upon 3 minus pi upon 3. So now 2 pi minus pi is nothing but pi. So you get as pi upon 3. That is 2 sin inverse x. And still we can simplify here. Here 2 is multiplying, go to that side division. So sin inverse x is equal to pi upon 3 2s are 6. So now x is equal to sin pi upon 6. So sin pi upon 6 is nothing but how much it is? It is nothing but, you already know that this as half. So you get this sin pi upon 6 is nothing but sin 30 degrees, that is nothing but half. So at last what is your answer here? Therefore x is equal to half, y is equal to 1. So that is about your problem number 25, and here it is 1 upon 2. So this is your 1 upon 2, and I hope so you all understood how to solve this 25 problem, and this 16 to 25 problem solutions you all understood. If you have any doubts, you can comment on YouTube session, and I am available to help you all. May God bless you all. Thus we completed this chapter number 2, and tomorrow next class we are going to discuss all previous year questions. Then I am going to conduct exam for you all. May God bless you all.